All right, so we're going to do an example of using log functions in applications. So we're going to do an application problem. So I'm going to read it to you and then we're going to work it out. So it says, the intensity I of an earthquake is measured by a seismograph, a device that measures amplitudes of shock waves. I sub 0, or I naught, I sub 0 is a minimum reference intensity of a zero level earthquake against which the intensities of other earthquakes may be compared. The magnitude M of an earthquake of intensity I is given by the following. Okay, so we have this formula. So the magnitude, is given by the M is equal to the log of the ratio of the intensity of the earthquake divided by the reference intensity. So this I sub 0, or what we call I naught, is the minimum intensity of a zero level earthquake. So meaning that it has a magnitude of 0. Okay, so this is the reference, okay, the reference intensity. And then this is the intensity of the earthquake that we want to compare it to. Okay? Okay, so now, A says, determine the magnitude of the earthquake that devastated Haiti in 2010 if the intensity was approximately 10 to the 7.0 times I naught. Okay, so it was 7 times the intensity, which means this ratio here would be 10 to the 7.0. Right, so this would end up being M is equal to log, and then the comparison, they're saying it was 10 to the 7.0, so they said it was 10 to the 7.0 times more intense than what? Than the reference one. So that means this ratio then would be equal to this. Okay, so that's what we're going to do. So that means that we're going to replace this with 10 to the 7.0. And then the properties of logs tells us that, well, this is a common log. This is the base 10. This is base 10. So this is end up being 7.0. So the magnitude of the earthquake that is 7 times more intense than the reference earthquake of a reference intensity, right, of a zero level earthquake is 7. Okay, now what about B? B says determine the magnitude of the earthquake that devastated that was in near Washington D.C. in 2011. That was 10 to the 5.8 times as intense as the reference. So again, we're going to do the same thing. So that means that we're going to just replace this ratio with 10 to the 5.8. And likewise, what's going to happen is the log and the exponential, right, are going to drop out because we're using the property of logs here, and we're going to get a magnitude of 5.8 on the seismograph. Now, C says, how many more times intense was the earthquake that hit Haiti? Okay. So now what we're doing is we're comparing the two earthquakes. It says how many times more intense was the earthquake that hit Haiti? So that means we want to compare their intensity. Well, there's a couple ways we could do this. We could look at the fact that these are just exponents, right? And so we could look at just comparing the two, right? And then just subtracting their exponents. Or we could just look at, okay, so there's a couple ways we do this. We could take how many times each one was, right? So we know that the one earthquake was what? 10 to the 7.0 times whatever the reference intensity. So we know this in Haiti was this many times the reference point. We know that the one by Washington, D.C. in 2011 was this many times the reference point. And so we can just use those intensities and divide them. Right? Because if we're going to compare intensities, let's use the fact that this earthquake was 10 to the 7th power times as intense as the reference one. The one in Washington, D.C. was this many times more intense than the reference point. And we could just divide these two, because if we're going to compare them, we always divide. That's always a good way to compare two values, is to just divide them. And anytime they say, well, how many more times intense, we're going to divide those two. So, and the cool thing is these will drop out automatically, and then it just becomes using the power rules for exponents, right? So the property of exponents says if you have two exponentials and you're dividing them and they have the same base, subtract the exponents. So we get 10 to the, and we always do top minus bottom. So it's going to be 7.0 minus 5.8. And so we get 10 to the 2.8, oh, not 2.8, 2.2. No, hold on a second. Oh, no. I don't know how to subtract. 1.2. Okay, so what do we get? That means that the earthquake in Haiti was 10 to the 1.2 times more intense than the earthquake in Washington, D.C., or near Washington, D.C. And so if we put this in our calculator, this is approximately 16 times. So we would say that the intensity of the earthquake in Haiti was 16 times more intense as the earthquake that hit near Washington, D.C. Okay, now, that was one way we could have done it, but another way we could have done it is just look at the magnitudes, right? Compare the two magnitudes. Now in this case here, if we look at the magnitudes, well, if we subtract the two magnitudes, in this case we wouldn't divide. We would not divide because again, these magnitudes are just numbers, right? So they don't represent intensity, right? But we could still do this. We could subtract the two numbers and see how far apart are the two magnitudes. And so if we subtract these two, we get 1.2. And then if we realize that this is just an exponent, right, because that's all we had here, then we would say, okay, if this is the difference in magnitude, then the intensity, the how many times more intense one would be from the other would be this. And we get the same number, okay? But it's important to know how you get that number, and the way we get this number, since they're talking about intensities, comparing the intensities, we want to go back and use the intensities, or at least the factors that they gave us, okay? All right.